All right, welcome everybody to a brand new day of computer science. Today we're just going to work a solution to the data science homework assignment where I've got on here a file called DS salaries, and this has how many, like 600 different entries from a survey on how much money data science people get paid. So we're going to use the data science to examine the data science. And what you have to do for your data science homework due on Friday is you have to ask 9 interesting questions and answer it using the data. So on here, you can see that there is year. So this is 2020, 2021, and 2022 as the sources of data. We've got mid-tier, senior, entry-level, and executive are the 4 different levels of jobs. We've got full-time versus part-time. We've got different titles here, which machine learning specialist, big data engineer. He's not just a data engineer, he's a big data engineer. You've got your salary in Great British pounds, and then this one here is normalized US dollars, which is what we're going to be using today. And so I'm gonna run you guys through, like, if my report was going to be on the data science salaries, which you can't do now. Sorry, I'm claiming it because I'm going to give you the code to do this. I'm going to show you what it's like to run through the homework assignment. So we're going to speed run the data science assignment today. The country of origin was Great Britain. They're 50% remote, and it's a medium-sized company. So you can have a small company, medium company, large company. And now we can ask all sorts of interesting questions, like, do large companies pay more? Do small companies pay more? Do you get paid more if you're 0% remote, 50% remote, or 100% remote? Who's the highest paid person out of this whole data set? Where do they live? Are they in US? Which countries are represented? There's a lot of interesting questions we can ask here. So we're going to start off by just showing you guys how to parse a CSV file once again. So we're going to say ifstream ends opening up dsSalaries.csv, which I'm going to misspell intentionally for a reason. Whenever you open a file, the first thing you should do is, everybody, what should we do when we open up a file? What's our best practice here? Whenever we open a file, we say what? If not ends, yes. Did the thing fail to open, right? So we can say cout failed to open file. And I actually had a student who was wondering why all of their reads down below were not working. Like, is it a squirrel? What's going on here? Is it, And I'm like, you're not opening the file properly, And so if we do this, compile main.cc and run it, you'll see that you always want to check to make sure you spelled the file properly. And even if you did spell it properly, like, I could now, move or remove, the file itself. So whenever you're working with a file, compile. How about now? Okay. Now it works. Okay. So every time you're opening a file, you should always make sure that it works, because, the file system could go down. They could rename. They could delete the file. You could mistype it. There's a lot of reasons why this will fail. So always double check. All right. So now we're going to go into an infinite loop where we are going to be reading all the rows out of the file. But before we do that, let's open this file up again, vim ds salaries. The top row here is the column header. And I think we can just throw that away. I mean, we could keep it, I guess, if we wanted to. But I'm proposing just throwing it away. Do you guys want to throw it away? Do you want to use that for something, or should we just pitch it and just get right into the reading of the meat of the data? What do you guys think? We could hang on to it for some reason if you wanted to print out, something, I guess. I don't know. This data, of course, came from Kaggle. DS. Throw it a guess, not really relevant to the data analysis, Let me log in here and show you where I got it from. Okay, so let me show you what this looks like in Excel. Excel is capable of opening up CSV files as well. And so you can, I'm going to have this up just because it's a little bit easier to see, I think, than having it in that text instead of putty. Okay, so there we go. Close that view. And so you're going to download it from Kaggle and WinSCP it onto the server. Okay. So now we're going to go into our loop, and we're going to read all of this into a vector of strings named CSV file. And so that is a two-dimensional vector of strings. And so what we're essentially reading in is this. For every row, for every column, there's going to be a string, like string 87000, not 87,000, the integer. It's going to have a string at that row, at that column. We're going to just read this two-dimensional table of data into a vector of strings. Okay, so we're going to read one line at a time. So we're going to say string s equals read line, and then every time you're reading from a file, what's the first thing you should do? What's the error that you're going to get every time, guaranteed, when you're infinite looping reading from a file? What's the error that could have occurred here? Infinite loop, read a line, read a line, read a line, read a line. What's the error though? Yeah, the correct answer is if not ends. But what are we actually checking for here? When will this happen? Yeah, I know. We want to put a break here. Absolutely. You're absolutely right. But when will this happen? When will we end a file? Very good, very good, very good. Okay. Break on the end of file. Okay. So now that we've got a entire line, what we've got here is like we've got a string containing this entire thing here. And this is not very useful to us. We need to split this into a vector of strings. And we could put a true, which would be cleaner, but, you know, I have no strong opinions on that. Okay. The only reason why you'd want to do it this way was so that if the file was invalid here, it would skip it. Okay. So, because we're not checking to see if there's an error here, right? So this, you know, if you change this to be while true, you're not going to notice any difference. Either way is good. This is the important one. This one here stops you from having a runaway loop, which is why I do it, just in case you put in continues and things like that. I like having the ends here as just a fallback safety measure, but technically while true, and then here having the this is the main check. Okay, so now we need to split the line, which is holding some like 0, 20, 20, you know, was it mid, etc., into a vector of strings. Okay. We need to split it into a vector of strings. So we're going to need to make a vector here, a vector of strings called temp. And what we're going to do is read until a comma and then put that into the vector. Read until a comma, put that into a vector. And this is going to work fine unless you have commas within your column, in which case you will need a little bit more complicated code. But we're going to ignore that for now because that's technically extra credit for this assignment, and I don't want to give you the extra credit for free. Okay, so we are going to convert the string into a string stream. So we're going to say iString stream ISS out of S. Convert a string into a string stream. In order for this to work, we need to hashtag include a string. Thank you. It's not really converting it. It's not exactly the word. use a string as a string. Yeah, makes a little more sense. Because it doesn't actually get rid of the string. The string's still there. It's just going to be parsing that string, which has 0, comma, this. It's going to be reading from that string as if it was reading from a file. And what we're going to do is we're going to do another while, maybe while ISS, or if you want while true. Either way is all good. And I'm going to do string, I've already used s, stir. Now, if I did string s here, notice that it's not giving me a compilation error. If I did it here, it would. Why? Why is it bad here, redefinition of s, but if I put it here, it's fine? Is the compiler broken? Is C++ a stupid language? Why can I have an s here? And if I have an s here, it's equal to honey bear. If I see out s, this is going to print out honey bear. It's not going to print out whatever's in that. In fact, I can't use that s anymore at all here. It's inside that new while loop. Yeah. So the restriction is you can't have a variable, you can't redeclare a variable inside the same scope. If you have a different scope, it's fine. And this is called shadowing. So this is actually going to shadow the s variable in the outer scope. So this guy lives in this scope from here to here. We're in a narrower scope, and a nested scope. And so because we're not in the same scope, we can actually redefine it. And the reason for this is so that if you've got like a big complicated project, especially if you have like a global, you can shadow it and you don't have to know the name of every variable and every scope enclosing you, which whether or not that's a good idea, I don't know. Maybe it is, maybe it's not. This personally is code that I would not write because now I cannot access the S here. And it would probably confuse people. Like if you scroll down, you'd think this is this S, right? If you just see me printing S out. So I know it's hard. It's the hardest thing in computer science, but you gotta come up with a new variable name. Okay, so we're gonna do that. Okay, so we are going to now do string stir equals readline ISS until there is a comma. This is the heart of parsing a CSV file. CSV is comma separated value, so we read until there's a comma. And again, this will work unless one of the columns has a comma in it, in which case you, again, have to do a small amount of logic on top of it to make it work. It's not bad, but at the same time, I'm not going to give it to you. So I'm going to leave that as an exercise for the reader. Okay, so we're going to read until the next comma, and then let's just print it out. Cout the stir. Here. Turn the AC on. And let's actually just do it like this. So we're going to read, and then, yeah, we need the if not ISS break. Okay. And so you can see, here's all of our data. Looks good to me. Neat. Okay. So now that we've got our data, then we are going to push temp.push back stir. So we're going to add to our vector. And then after we've, this is going to have vector.at 0 is equal to, what's the example we're using? 0. Okay. Vector.at 1 is equal to 2020. Vector.at 2 is equal to mi. You guys see what I mean? Like if this is our sample data here, then what we're doing is we're putting the 0 into the first element of the vector, putting 2020 into the second element of the vector, we're putting mi mid into the third element, also known as vector.at2, which is the third element. Yeah, see that? So we're taking one long string that has all these comma separated values, and we're putting each one into its own slot in a vector. Does that make sense? So we've got one string containing all of this data, and we're gonna put, it's like what Excel did here. Like this guy's in his own column, this guy's in slot 2, slot 3, slot 4, slot 5. Instead of it all being like one long line of text, which you can't really do very much with. It's been separated out. They're all strings, mind you. This is a string. It's not a number. But, okay. And then once we got this, in fact, we don't even have to call it temp. Let's call it row, because we're basically parsing one row of data at a time. And then CSV file dot push back row. So we've just read one row of text. We've split it into a vector of strings, dot at 0, dot at 1, dot at 2, dot at 3, et cetera, et cetera. And now we're going to add that to the CSV file. So at the end of the day, we're going to have a giant 2D data structure full of strings, with each column, each row having a string inside of it. And then this will allow us to do things like average all of the salaries by just going down column 7 here. Or we can count how many times the US appears in company location, or things like that. Or we could, only look at the 2020 data if we wanted. So once we've got everything loaded up into a 2D, which is essentially what we have here in Excel, a 2D data structure of strings, 2D vector of strings, then we can do our parsing, our analysis rather. Okay, we're kind of doing the parsing right now. Okay, so that should be good. So now let's print it out. So for every let's say const auto by ampersand row. So for every row in CSV file, for every const auto by reference column, for every column in the row, we will see out the column followed by the tab character, and then see out the endline character. So this should give us the exact same data as before, which we get. Cool. So we're getting the exact same data as before with tab separated values and all that kind of stuff. Okay, so there's all of our data. So all of our data is successfully loaded into the CSV file. It is now time to begin an analysis. So what do you think the easiest kind of analysis we could do is? We got to answer 9 questions, and they got to be different. I don't want you just doing the same thing. Like, what is the average salary for America? What is the average salary for the UK? What is the average salary for Hungary? Nah, you got to mix them up a little bit. Okay. So what is the most basic question we could ask on this data set of data science salaries? What do you think? It's the easiest question. Median? No, median is not the easiest. Median is not the easiest at all. Average is far easier than median. To do median, you'd have to sort it. You'd have to sort all the rows based on the salary, and then pick the middle element, right? Average is much easier than median. Okay. Highest or lowest, sort the vector. Yeah. Okay, let's do highest first. I guess that's who got paid the most. That's a good one. Okay, so we can actually just kind of save this. So this is code to print the 2D vector. Okay, but I'm going to save that because I'm actually going to use the same thing here. Okay, so for every row in the CSV file, so it's going to be like going row 19 or 20, whatever, I'm going to be looking at salary. No, I'm going to be looking at salary in USD. Because this guy here is getting 1 million Hungarian francs. I don't know what the F stands for. But in reality, they're only getting paid $35,000 a year. It's like Zimbabwe dollars. Have you guys ever seen the 100 trillion notes? You guys ever seen these things here? So back in the day, they were really, really cheap. And so just as a joke, I bought a stack of like 40 of them. And I would just like give them out to students. Like, oh, you got a question right. Here you go. You know, and like they would just use it as a bookmark, or they're like, ah, ha, ha, whatever. They would walk out of class and throw it in the trash. Like, oh, you know, whatever. It's 40 cents. You know, they don't care. Look at the price of this now. I'm a little bit upset at the students that were like, oh, haha, thank you. And they pitched it. It's $100 now. I gave out a lot of these to students. It's just like, you know, little cutesy rewards. Like, You knew the name of Obi-Wan Kenobi. Here you go. Here's $100 trillion. You're a trillionaire now. Now it's 100 each. So I'm a little bit. I even have them over here somewhere. Yeah, so these are all. Oh, these are 50s. Okay, they're the hundreds. Yeah. So you can see all the 50s and hundreds that I have from Zimbabwe. I bought them for like nothing. It was like $20 for like a stack of hundreds like this. Now they're $100 each. And I was just giving them away left and right. You got that partly right. I'll give you a 50 instead of 100. And students just were like I said, they're just like throwing them away. Not on the inside. Yeah. So I told them, I'm like, you're a trillionaire now. One less thing you have to worry about. Sad. If I had only kept them, I could have been a trillionaire. I am a trillionaire. I still got some. Okay. So, yeah, we want to do what? Max salary. All right. So for every row, like let's say we're just arbitrarily here, we're on row 20. We want to get the salary in US dollars. We do not want the Zimbabwe 100 trillion. We want the salary in US dollars. And so this is column 0, column 1, column 2, column 3, column 4, column 5, column 6, column 7. So column 7 is the salary in normalized US dollars. We want to find the biggest one. Okay. So let's do this. Integer max is equal to 0. Am I handling negative income? No, because I don't allow my students to work for internships that they pay for, not allowing negative income. So yeah, so my code is not going to handle. My code will not handle negative income. Oh well. Okay. So we're gonna. Do you understand? Because like if all of the incomes were negative, then it's going to say the max is 0, but the max would actually be whatever the biggest negative number is. I'm not handling that because I don't believe in unpaid internships. You're worth more than that. You're worth at least minimum wage. Okay. So the current income of the current row, what do we say, dot at 7? So row dot at 7, that's going to return a string. And we want to say int current is equal to string to integer. So we have to convert it from a string to an integer, like that. That will give us the 100,000 or whatever it is in integer world. And we're going to say if the current amount is greater than the biggest we've seen, then the biggest we've seen is equal to the current amount. And at the end of the day, we will simply output the biggest amount and see what we get. 600,000. You guys want to know where? Which position this is? You want more? Would you like to know more, like in Starship Troopers? Would you like to know more about this person? Yeah? No? Do you want to know more about this position? Is it remote? Is it local? Yeah? Okay. Well, watch this. Vector of strings named temp. Just an empty vector of strings. So what we can do is every time we find a new biggest row, biggest salary, what we can do is we can actually say temp is equal to the current row. You can actually copy an entire vector to another vector of the same type. So we had a vector of strings. We're just copying all the data out. Now instead of just printing out the highest income, what we can do is do a little range-based for loop. So for const string by reference s in temp. So for every column in temp, that's, in other words, we're copying out the entire vector of strings like this. So we're just going to print the whole thing out. Okay. We will see out the column followed by the tab character, and we will then see out like that. And there we go. So this is our information. Let me get my face out of the way. So the number one paid data scientist in this study is somebody called a principal data engineer. Sounds fancy. They are full-time. I hope so. They're an executive, so they're not like a working stiff. They're a C-suite person. They're making $600,000 US. They're based out of the US. They're 100% remote, which is interesting. It's very interesting that it's a completely remote position and they're getting paid $600,000 because, you know, they could be working another job at the same time and nobody would be the wiser. You know, why stop at 600 when you could get another, you know, $200,000 job and, you know, be double employed. If you're remote, nobody knows. Based out of the US, and they're working for a large company. This was 2021. Okay. We haven't, you know, I don't know what happened to them in 2022. Maybe they got fired. Being fully remote in 2021. I don't know. Okay. So 24/7 virtual meetings. Nah, like nobody's in a meeting that much. So that is our number one winner. Okay, so the other another person wanted to say, what's the average salary, right? What's the average amount of money they get? So we can do that. Okay. I've got in the public directory, I've got all this code for you guys. Okay, so if you want to do the average salary, so let's make this a double total, just in case there's a possibility we overflow. I don't think there is, but just in case. So we're going to say total plus equals row dot at 7. So I want to add the salary of every person. So basically for every row, we're going to grab element 7, which is the income column, and we're going to add it to the total. We're going to add all these together, and then we'll divide by the row count, which is the size of the table, to get the average. So why is this not compiling? What is the type of row? What is this guy here? Why can I not add vector.at7 to the total of my salaries? Anyone see? It's a compiler error here. Invalid operands. Yeah, it's a string. You cannot add a string to a double. So we need to stot it. Okay. Like that. And then that's going to add up all of the salaries. And then to get the average, we just say total divided by CSV file dot size. That's the number of rows. So that is how many rows we have. The size of the table is the number of rows, because it's a vector of vectors. So that is the number of rows we have. And assuming the table is non-zero, then we get a valid answer. So that is another answer we could have for our data science assignment. We've done 2 of them now. Who's the most paid data scientist in the data set? What's the average salary for a data scientist in the data set? Now, Olson wanted to know what's the median salary. So to do that, we're going to have to sort the 2D vector based on salary and pick the median, unless you want to do some fancy algorithms, which I don't have time for. So yeah, okay, fine, sure, let's do this. Do you guys want to? Do you want to see the easy way of doing this? I'm going to go. Oh, I didn't go blurry. Amazing. Do you guys want to see the easy way of doing this, or do you want to see the job security way of doing this? The easy way? Okay. All right. So, okay, so we want the median. So we need a way of sorting a 2D. We need a way of sorting this, right? Like in Excel, what we can do is we could select column 7, and we can go to sort, and we can say sort largest to smallest, let's say. And it says expand the selection, yes, and then boom, it's sorted. So we want to sort it using column 7. we have a 2D thing, and it's these are numbers, right? So we want to sort this 2D array of strings, 2D vector of strings by column 7. And so we can do this with a custom sort function. So I'm going to say Boolean custom sort function, which I probably could have a better name for, but whatever. And we're going to take two different rows. We're going to take a vector of strings by reference named row 1. We're going to take a constant vector of strings named by reference row 2. So given two different rows, like if you hand this function this row and this row, like let's take row 11 and row 12 here. If we hand the function row 11 as row 1 and row 12 as row 2, which one is bigger? Which one is bigger? Just looking at the data here, guys. Which row is bigger, 11 or 12? 11's bigger, right? Now your sort, I guess it depends on whether or not we want to sort least to greatest or greatest to least. It's not going to matter because we're doing median and median's in the middle, so it kind of doesn't matter at all. But do you guys want to sort least to greatest or greatest to least? Least to greatest is the default. And we can do that. Least to greatest, okay. So I'm going to return row 1 dot at 7 less than row 2 dot at 7. So we are sorting the rows based on their salary, but these are strings, and so this is going to do an alphabetical sort, which is not what we want. We want these guys to be converted to integers. So we have to stoy them like this. And then that, my friends, is how we make a custom sort function. So given two rows, because C++ doesn't know how you want to sort it, right? So you have to tell it. We want to say one row is less than another when its column 7 is less than another's column 7. And if we do that, then watch this. Sort CSV file dot begin, CSV file dot end. So we're going to sort from the beginning to the end of the Excel spreadsheet. And we're going to pass in custom sort function. Just like that. Notice, you would think there should be some parameters here, right? Nope. And thank you, Commander of Completion, for filling that in for me. You would think there's supposed to be a parentheses here. Nope. Look at this. Look at that. There's no parentheses there. I'm not calling the function. What's happening here is I'm passing the function to the sort function. So the sort function is going to use this function here to sort the table. Okay? So it's going to sort the table from the beginning to the end using my custom sort function to sort it. So it's going to sort the rows from least to greatest based on salary. So if maybe I shouldn't have deleted the print functions. I need to do it again. Const auto row CSV file. I literally just deleted this. For every const auto by reference column and row. See out all. Not the end of the world. And there you go. So you can see here, that is our highest salary. We sort it least to greatest, right? And then research scientist is getting 450. Financial data analysis is getting 450. Applied machine learning scientist is getting 423. Principal data scientist. These guys are mid-tier too. That's the best part. These guys are not even seniors. They're mid-tier. Got some executive levels here. Executives, seniors. Most of these are seniors, but some of these guys are just mid-tier. And they're getting 270 a year. Not bad. Not a bad. Head of data. That's a cool name. Head of data. Data science manager, 240. Director of data science, 250. Yeah. So we have sorted the table from least to greatest. You guys see that? So that's our highest salary. And if we scroll up to the very top. Where's the top? There, yeah. That is not a great salary there. So they're making $2,000 a year full time. It's not a high salary. And this person is full time, making $4,000 a year. This person is making $5,000 a year in India. Not big bucks. Okay. Ah, yes, the negotiator must live in California. When you count columns of data, do they start at 0 or 1? 0. So in Excel, they start at A. Right? And the rows start on 1. And the columns are A and B. That's actually a job interview question at Microsoft. Convert Excel column headers to numbers and vice versa. So we want to get the median. We want to get the median value, right? So now that we've sorted it, that was the hard part. That's the hard part. So let's put this into the code graveyard here. Not going to delete it again. Let's just copy the entire vector out. So vector of strings named mid. He's very mid. Right. And so the middle entry is going to be mid is going to be equal to CSV file. The middle row, like let's say we have 100 rows, row 50 is going to be the median. And if it's even, then you technically are supposed to take two values and average them, but I don't care. I'm just going to take whichever one it rounds down to. So CSV file dot at CSV file dot size divided by 2. This is the median person, whatever the median salary is. We've got 500. It's going to be close enough. I'm not going to worry about rounding up or rounding down on this because I don't care. Okay, so then we're going to say for every string s and mid, I should make that const reference. I'm not, I don't care. Cout s followed by the tab character. So let's see who our mid engineer is. It is a data engineer from the US making $101,000 a year. So $101,000 a year is the median salary, which is not the same thing as the average salary, the median salary. And it is a full-time senior level position called data engineer based out of the US at a medium company. There you go. Olson, you got your answer. So we've done 3 questions now. All right. Give me another question. There's lots of interesting data here. You know, do US jobs get paid more? Do large companies pay more full-time versus CT? Cut time? What is CT? Overtime? Part-time? Foot and ankle CT scan? I'm pretty sure that's not what they're talking about. CT tech. Doesn't say what CT is. Once awarded the CT or FT certification, what is it? What is it? I don't even think thanatology? What the heck? Study of death? What have we stumbled upon here? What is this? Death education and counseling? My lord. Okay. Let's back out of that. I don't know. That just got dark, really. I don't know what CT means. I'm assuming it's part-time. But I can't assume that because this person is making a heck of a lot of money for a part-time position. So there's almost no... Everything's full-time. There's a couple. CT, 100,000. Oh, what? There is a part-time. All right. FL? What is FL? Full? I don't even know that. Okay, anyhow. Don't ask me what they mean. I don't know. FL, yeah. Okay, hire rate. Do they look for more data engineers and software engineers? That's going to be kind of annoying to deal with because it's not just like there's data engineer, but there's like lead data engineer and data engineer, and those are two different answers. And so we would have to like group them, or maybe not. I don't know. Head of like what is a head of data science? Like to me, that's the same thing, right? But like if we just did based on a string comparison, those would be two different things. So I don't want to do that. It would actually require like going through the data set and probably like cleaning it up or something, and I don't want to do that right now. There may be documentation. True. Okay, give me another analysis. What do you guys want to see? We do 2020 versus 2021 versus 2022. Our salaries going up. Broadly speaking, it's not a very good analysis because the mix of jobs might be different, but it could be interesting. What country gets paid the most on average? All right, yeah. All right, that's a good one. That's good. I think it's our time for a who fires the most people. I don't think we have data on being fired. I think it's just people that have jobs. Good question though. Maybe if a job existed, like the guy that got paid $600,000, he's in the 2021 survey. He's not in the 2022. Maybe they wised up and realized that paying somebody $600K a year to be on Skype isn't worth it. Who knows? Okay. All right. So, what country gets paid the most on average? All right, that's a good question. That's a good question. And this is what's fun about data science, is that you can just sort of like if you have an interesting question, you got the data here. Assuming you have the data here, like we don't have firing data like you're asking for. But if you have the data here, like you can write a little bit of code. Like you can see each one of these answers are like, about that big. Just kind of spit them out. The hardest thing for you guys is like, you didn't know that you could do a custom sort function. And that's why I'm showing you. So you can get that experience. Okay, so which country gets the most money? So what we need to do is do a map, between the string for the country, and we'll just have an integer tallying up all of the salaries, and maybe we'll do another one to keep track of the count because we need to know how many times the US shows up so we can average it. Yeah, let's do that. Okay, so let's do a map, unordered map. Maps would be alphabetized. That'd be nice. Yeah, let's do a map. We don't need a hash map. We don't need a hash map. We're just going to use a regular map. That is a little bit slower, but it'll have everything nice and alphabetized for us. Okay. So I'm going to make a map between a string and an integer. We're going to overflow. We've got 600 entries. Biggest is 600K. Now we're fine. Integers. Okay. And this will be called salaries by country. And that's going to be gross. So that's all of the salaries added together. So the key will be like, like US or something like that. And then the value would be something like, some big old number that's the sum of all of the salaries. It's the gross salaries. Sum of all salaries. How about that? Okay. And then we also need to keep track of count by country. How many jobs in that country. And that'll actually give us another interesting data point, which is which countries have the most jobs, right? Now, it's probably not a representative survey of the world, but, just out of curiosity, which countries have more data science jobs than others might be an interesting question to ask. To the extent that the survey that they did here is limited and so on and so forth. So we'll actually get a twofer on this one. We'll get two different points of analysis for one little bit of code. Okay, so again, we are going to run across for every row in the CSV file. So in other words, we're going to look at, this row, and then we're going to look at this row and this row and this row. And so we want to get the country that they're in. So we've got two different ones. We got the employee. Oh, I see. So they don't have to live in the country they're employed. It looks like it's a for everything. Maybe. Oh, no, this guy lives in Spain and works remotely in the U.S. Okay. So which one do you guys want? Like country of residence, or do you want the company? Probably the company's location, right? Like which countries pay more, you know? Oh, FL is freelance. Oh, interesting. Yeah. All right. Do you guys want the company's location or the location of the people who are working in the company? We can do either. Payment may be adjusted by cost of living. True. Residence. Oh, interesting. Okay. Like where they live. Okay. See if there's many. Oh, okay. This guy. So it's going to be pretty close. This guy lives in France and works in Spain. This guy lives in the U.S. and works in France. Interesting. Okay. Okay. Oh, yeah. So we're going to do this one. We're going to do where people are living. Okay. So this is column 0, 1, 2, 3, 4, 5, 6, 7, 8. So we're going to be looking at column 8. So string country is equal to row.at8. This is why it's so nice to split a row into a vector of strings. You just grab column 8. For every row, grab column 8. Cool. Now what do we do with it? All right, so that's their country, and then we want to have their salary int salary equal to row.at 7, and we need to store that string to integer. So we've got their country, we've got their salary. That's all we need. Okay. So now we're going to put this into the map. So salaries by countries doesn't sound right to me. Let's make this salary by country. That sounds a little bit more. Okay, so salaries by country, square bracket, country, plus equals salary. Boom. So this is going to add together the salary, and each country gets its own bucket. So this would add 13.5K to the US. This would add 150K to the US. This would add 20,000 to Hungary. Yeah. What country is Honolulu? Honduras. Gotcha. Okay. So each country is going to have its own slot in the map. So there's going to be one key for the US, and all of these salaries for the US are going to get added together. And then we also need to add to the count. So count by country. So if we've seen another US country, we're going to increase the count by 1. And so we're going to add together all the salaries for the US. We're going to add increment. Hey, we've seen another US country. Then we read another country. It's India. Okay. Let's take the salary for this person and store it into the slot for India. Add it to the slot for India. And then we're going to increment the count for India by 1. Okay. And at the end of the day, we just output the whole thing. Yeah. All right. So for const char string int p, not by reference because they're kind of weird, out of salaries by country, we are going to output p dot first. So whenever you work with a map, it's going to return a pair, which is both the key and the value. So it'll say the key is US, the value is 4.2 million or whatever. So it's going to return both, and you get the name, the key using dot first, and you get the total amount using dots second. But we're actually going to divide dots second by the count. So we want to do that, and actually let's compute this. Okay, so integer average is equal to salaries by country. P dot first is the name of the country, like the US. So that's going to grab the total amount of salaries for the US. We're going to divide this by count countries. P dot first, like that. And so the US will have a value of something, and we're going to divide by how many times we've seen US come up, and that's going to be the average. Okay. And then we'll just output the average. Okay, so we've got here, it's alphabetized by country, right? So Australia is making 108. China is pretty good. Colorado, wait, who's Puerto Rico's got some pretty good. Malaysia, maybe 200,000. So the U.S. is averaging 149,000 a year. India is averaging 37 a year. Russia is 105. España is 57. France is 59. Great Britain 81. Go America. We're paying more than all these European countries. Czech Republic 70. That's actually higher than I would have thought, because I mean that's very close, like Great Britain salaries, and it's like ridiculously cheap to live in Czechia. Like it's like everybody always says, like when you go to Europe, you should visit Prague for two reasons. First of all, Prague is amazingly beautiful, and the people there are friendly, and it's just gorgeous. It's a gorgeous city. The other thing they always talk about is how cheap everything is. Like, if you go to the train station, order a coffee, it's $5 or whatever, just like it is in America. But if you leave the touristy areas, like I bought a bottle of water, like a 2-liter bottle of water for like 70 cents or something like that. Like, and the people in Prague complain about how expensive Prague is. Like, it's not cheap by Czech standards. So like when I went out into the countryside, the Czech countryside, it's very, very cheap. And that's a really good salary. So, you know, maybe one of my life's ambitions is to go to work for Warhorse, the people that made Kingdom Come Deliverance. You know, at 70,000 a year, you could live like a king, I would say, in Prague. That is not a bad price at all. And you're getting paid more than in Spain, in France. Heck yeah, dude, it's awesome. Okay, yeah. You sort of the least from greatest to least, or like countries where there's only a few workers. Okay, so we're gonna need to now have the count listed also, right? Okay. Fortunately, we have that. We have count by country, so we can just slap a little parentheses on here. Do count by country. P dot first is the name of the country, and then we'll do a close. That. Okay, so now we've got a count, right, with each one. So Czech Republic, oh, it's only one person. Okay, yeah, I was getting too excited there. España has got 15 people. France has 8. Great Britain is 44. So where are the jobs at, right? Where are the jobs at? America, 332. Go America. We're number 1. Cue the bald eagle noises, which sound suspiciously like red-tailed hawk noises. I don't know if you guys know this, but like bald eagles actually don't go. You know, that's a red-tailed hawk that they always play over the bald eagle for some reason. I'm not sure why. Yeah. Australia's got 3. New Zealand's got 1. Okay. Yeah. A victory for American exceptionalism. That's right. Foreign Russia. Netherlands with 5. Yeah. Check us out. We're number 1. Okay. Yeah, Great Britain, I think, is number 2 at 44. Okay. Yeah, so if we wanted to sort this by average salary, we would need to put it into another vector and do a custom sort again. I don't want to do that. I'm good on this one. Okay. So that's pretty good. I think it's a pretty good stopping point. Maybe I'll show you guys one more, like how to break it down. Like, do you guys want to see how to like average salary of entry level versus mid versus senior, you know, that kind of stuff? You guys want to see one of those, like, you know, what's the average salary for entry level, mid tier, senior, exactly. All right, because that's a pretty good example of how you do stuff. All right, so we'll probably do the same kind of thing. So, I mean, I guess we could literally do the same thing, where except instead of a string being for the country, the string would be for, what do we call entry level? Like, it's just entry level. Okay, Ian. Right. So instead of using the country codes, we would just use senior, MI for mid, SE for senior, Ian. You guys understand? It's literally the same code. Or we could just not use a map, I guess. If you guys want to see how to not use a map, we could do it the slow way, I guess. So entry, salary, $5S, mid salary, senior salary, executive salary, Y4Y, paste. And we could go entry success count, dot, dot, dot. So we're essentially doing the same thing. Like we're going to add up the salary of all the entry level people, then divide by however many entry level people there are. So if there's 50 entry level people, we add up their 50 salaries together and then divide by 50 to get the average. So it's literally the same thing that we did before. We're just doing it less well. But maybe more CSI 40 friendly. I don't know. Like maybe having 8 variables is easier on your brains than, I don't know. Which way do you guys prefer? Do you guys prefer having just a crap ton of variables like this? Or do you prefer having like one track of all of your salaries, one track of all of your accounts? And I'm going to show you this way just because I've already shown you that way. It's the same code. You just change, you literally just need to change that to column 2 and be done. You need to know how to use the variables more. Yeah, I'll just show you. This is a more CSI 40 friendly way of doing it. Okay, so for every row in the file, if row.at2, right, column 0, column 1, column 2, and I should not be using 2, 7, and 8. I should have like constants and things like that. You know, for this data analysis, like this is, you know, like this is the kind of thing where like you run it, you get a number, and you just throw the code away. Like you don't need, like, technically I don't need to keep any of this code because I can just remake it so fast. But you know, whatever. Okay, so if row 2 double equals entry level, then entry salary plus equals row dot at 7, which we're gonna have to stoy, and entry count plus plus. And we're gonna do this for entry level and mid tier and senior tier and executive. mid 5s mid dot. If they are SE for senior, then 5s senior, and if they are executive, 5s executive, and dot. Okay. So I think that's good. Did I miss anything? Whenever you copy and paste, you should always have a moment when you like look at it and be like, did I change all of these? Is all of these changed? Like every place where there's a point where it should be updating, you like look at it. Is it row column 2 for all of them? It is. Is that the same? Is that changed? Okay. Always double check your copy paste. It's probably the most common source of bugs. At least for me. Like I'll copy and paste and I'll change 2 out of the 3 and forget one. Okay. So that's okay. Okay. So what we've done there is basically the exact same thing we did here, except without a map to make everything simple. Instead of 2 lines of code, we've got like 16 or something like that. Well, whatever. Okay, we got tons of variables. It's all good. All right, so now we'll just output entry. Entry level is going to be entry salary divided by entry count. That's the average salary, and then we can do a little count here as well. Entry count. All right. YY3P entry 5. Yeah, this one's capitalized. Okay, so 5s mid dot 5s senior dot, and then for the last one, 5s executive dot. This is why I can't stand people not using Vim. They would rather type all that by hand. Okay, so here we go. Here's our final analysis for the day. Entry level makes 61,000 a year on average. There are 88 jobs. Mid-tier makes 88K a year with 213 jobs. Senior level makes 140 a year with 280 jobs. And interestingly enough, the modal response, the most common response, is actually senior positions. There's more senior positions than there are other positions, which is interesting. Then, of course, executives make the most, but there's also the fewest of them, which also kind of makes sense. So there you go. So I've done probably 6 out of, 9 questions for the data set. And I just type all this up. I just copy and paste these answers, put them into a Word document, type them up, send them in. Then on Friday we will do a little presentation where you guys can present your reports and talk about any interesting findings you guys found. So, one is easier to understand at a glance. The other is more efficient to write and also computationally. Yeah, I mean, ain't no way am I writing, for 4 variables, this is like kind of pushing it for like how much, I want to do this. Like, you notice how many copies and pastes I had to do. Like, I can do it. I'm not happy about it, but 3 or 4 variables, yeah, I guess I'll do it. But for countries, like, there's like, I don't know how many countries, like 30, 40, 50 countries. I am not writing, 100 variables for U.S. salary, U.S. count, Honduras salary, Honduras count, India salary, India count. No. No, ain't nobody got time for that. This is kind of pushing it here, but, for like years, you could do the same analysis. How much money did people make in 2020, 2021, 2022? You could do it with 3 variables, adding up all the salaries, and then adding up the count of how many people got paid in 2020, 2021, 2022. You can also look at, are there more jobs now, in 2022? It's not a very scientific study because, after all, these are just surveys, and who knows how many jobs there actually are. But it'd be interesting. It'd be interesting to see. So that is what you guys have to do for your assignment. So for the rest of class today, you guys have lab time. So I highly recommend you guys work on it. I don't need to see any of your code. If you want to send me your code, I'll look at it. But this is an open-ended assignment. It is your job to just do whatever kind of analyses you find interesting. And you're going to type them up into a report and send them to me by Friday. And then we'll do a presentation on Friday. So all of this code is available up on Public Data Science. That's actually from last year, I think. Yeah, that's last year's. And so this one's working a little differently, I think. Yeah, so this one actually doesn't read it into a 2D array at all. Just as it reads through the file, it's just grabbing column 7 and pulling the data out of it. Just adding it up directly. I find it easier to just put it into a 2D vector, and then you can run down the columns and rows and sort it and stuff like that. So I would grab copy /public /data science to your current directory, and that's got a copy of all the code from today. And that, adapt it. You cannot do the data science data set. I've claimed that one as my own, and I've already done most of the work on it anyway. So you cannot use this this data set. You're gonna find your own on Kaggle, but the code here you can use and reuse however you want, because what's important is not the code. The important thing out of this is the analysis you're gonna do. And this is what data science is all about. It's like you got a data set, you're trying to tell a story from it. Like, where should I go to get a job? Or it's an analysis we didn't do, but like, where are people working remotely? Which countries have more people working remotely than others? Which countries are they crossing the borders to work? Okay. Interesting stuff. Okay, so that's your, grab that file. I'll put it on chat for you if you want, and then for the next hour I'll just be hanging out answering questions for you guys. Get going on it. It's due on Friday. Peace.